It's their first taste of freedom. Researchers are releasing several Przewalski horses into the wild.
It's the only truly wild horse on Earth.
December.
In the winter of 1985, a convoy of trucks rolled across the edge of the Junggar Basin in northern Xinjiang, carrying something that made almost no sense to the people who watched it pass. Wooden crates, reinforced with steel bands, each one holding a living animal that had not set a hoof on Chinese soil in nearly 2 decades. Inside those crates were Przewalski's horses, small, stocky, wild-maned animals that looked more like something out of a cave painting than a living creature. The place they were being taken to was not a farm, not a reserve with fences and feeding stations. It was a stretch of cracked earth so degraded that local herders had stopped grazing it years earlier. Nothing grew there. Nothing moved there, except sand. To understand why anyone thought this was a good idea, you first have to understand what had happened to that land. And to understand that, you have to go back to a single number. 0. By 1969, the Przewalski's horse, the last truly wild horse species on the planet, distinct from every domesticated breed by an extra pair of chromosomes, had vanished entirely from the wild. Every horse alive belonged to a handful of zoos scattered across Europe and Asia, the descendants of a tiny founding population captured at the start of the 20th century. The species had come close to blinking out of existence twice, and by the time conservationists began seriously discussing reintroduction, there was no wild population left to reinforce. There was only empty land, and a question nobody had a confident answer to: could an animal raised for 3 or 4 generations behind fences remember how to be wild? The Junggar Basin itself was not chosen at random. It sits at the western edge of the Gobi, a vast bowl of steppe and desert wedged between mountain ranges, and it had been part of the species' historical range before hunting, competition with livestock, and the pressures of the 20th century pushed the last wild herds out. But by the 1980s, the basin had a second, more urgent problem. Decades of overgrazing by domestic herds, coupled with drought cycles and the loss of the natural grazers that had once kept the ecosystem in balance, had left large sections of the land compacted and lifeless. Chinese officials watching the region's slow collapse were not just thinking about an endangered horse. They were thinking about a spreading desert that was steadily swallowing productive land, and about whether there was any way to reverse a process that bulldozers, tree planting campaigns, and irrigation projects had struggled to slow down. That is the context in which a small group of Chinese scientists proposed something that sounded, to a lot of people in the room, like wishful thinking dressed up as science. Bring the horses back, not to a zoo, not to a fenced safari park, but eventually, after a long process of acclimatization back into the wild basin itself. The argument was that these horses were not simply a species worth saving for its own sake. They were, historically, one of the animals that had helped keep this exact landscape functional, and removing them had been part of what let the land start to fail. The plan that emerged, formalized in the mid-1980s, moved in careful stages. The first horses were flown in from breeding centers in Europe and North America and placed in a purpose-built center near Jimsar at the edge of the basin where they could be monitored closely. This was not a release. It was closer to a rehabilitation program. Keepers worked to gradually shift the animals away from the routines of zoo life, regular feeding times, enclosed shelters, minimal need to search for water towards something that more closely resembled the conditions they would eventually face on their own. Larger paddocks replaced small pens. Supplemental feeding was slowly reduced. The horses were left to figure out, in incremental steps, how to find forage and water with less and less human help. Even this gradual process was not gentle. The animals struggled. Skeptics inside and outside China pointed out, reasonably, that a horse born and raised inside a zoo enclosure had no practical experience with predators, extreme temperature swings, or long-distance travel in search of water. Some conservation biologists at the time were openly doubtful that the semi-wild phase would produce animals capable of surviving full release at all, let alone rebuilding a landscape. The Junggar Basin is not a mild place. Summers push past 100 degrees Fahrenheit. Winters can plunge to temperatures that make water freeze solid within minutes of exposure, and forage is unevenly scattered across enormous distances. Animals accustomed to a bucket of hay delivered on a schedule were being asked to relearn survival skills their species had not needed to use in generations. What kept the program moving forward, according to the scientists who led it, was not blind optimism, but a bet on something specific. That behavior tied to survival is not purely learned from a mother in the wild, and it is not purely instinct either. It sits somewhere in between. And some of it can re-emerge under the right pressure, even after it has gone unused for a while. The team wasn't expecting the horses to arrive as finished wild animals. They were expecting the desert itself to do part of the teaching, and they built the reintroduction timeline around giving the animals room to fail, adapt, and fail again without dying in the process. The transition into full wild release happened gradually over the following years, moving small groups from the semi-wild paddocks into progressively larger sections of the Kalamili Nature Reserve, a protected area covering a large stretch of the basin's most intact remaining habitat. Full, unassisted release, no supplemental feeding, no medical intervention beyond monitoring came later, once herds had shown they could locate water sources and survive a winter with only the resources of the landscape itself. The early results were mixed in exactly the way you'd expect from an experiment nobody had run at this scale before. Some horses adapted quickly, falling into loose social groups, exploring their new range, and locating water sources that keepers hadn't specifically shown them. Others struggled. Mortality in the first years was a real and openly acknowledged problem, and the program's leaders did not pretend otherwise in the reports and papers that followed. But the trend line, tracked over the following decade, moved in the direction nobody had been willing to promise at the outset. Survival rates improved. Foaling, the birth of new foals, began to occur regularly in the wild population, and behaviors that had not been taught by any human began to show up in field observations. Horses digging through snow to reach buried grass. Stallions positioning themselves as windbreaks for mares and foals during storms. Herds relocating ahead of approaching weather in ways that matched patterns seen in historical accounts of wild Przewalski's horse behavior from a century earlier, despite none of the released animals having any living connection to those older wild populations. What made the project significant in the eyes of the ecologists who kept coming back to study it was not just that the horses survived, it was what started happening to the land around them. Grazing horses do something that idle land does not. They disturb the surface. Hooves break up compacted soil, letting rare rainfall penetrate instead of running off. Grazing itself, when it's not overgrazing, tends to stimulate certain grass species to put out fresh growth rather than going dormant. And horse manure, unlike some other grazers' waste, carries a substantial number of viable seeds through the digestive process relatively intact, spreading plant material across the range as the herds moved. None of this was a secret to rangeland ecologists. It's a well-documented feature of large grazing mammals in grassland systems generally, but seeing it play out in a landscape that had been functionally dead for years was still a notable result. Researchers monitoring vegetation plots inside versus outside the horse's range began to document measurable differences in plant cover and species diversity over the following years. Differences that tracked with the horse's presence rather than with rainfall alone. That basic mechanism, a returning grazer helping restart a stalled grassland ecosystem, is not unique to Przewalski's horses. It echoes what ecologists have documented with other large herbivores reintroduced to degraded landscapes elsewhere in the world, from bison on the American plains to wild ungulates in parts of Central Asia and Africa. Grassland ecosystems, it turns out, often evolved with large grazers as a functional part of the system, not an incidental visitor. Remove the grazer for long enough, and the system can shift into a different, less productive state that doesn't easily reverse on its own, even when the climate hasn't fundamentally changed. Put the grazer back under the right conditions, and some of those old feedback loops can start running again. The Junggar Basin program was not a fast fix, and it would be misleading to describe it as one. It unfolded over more than 2 decades, tracked by successive teams of Chinese and international researchers, with population counts, survival statistics, and vegetation surveys published in scientific literature along the way. By the early 2000s, the wild population in the Kalamili Reserve had grown into multiple breeding herds, spread across a range far larger than the original release site, with new generations of foals born entirely in the wild, to mothers who had themselves been born in the wild. That detail matters more than it might first appear. At that point, an entire generation of Przewalski's horses existed in China that had never known a fence, a bucket of hay, or a keeper's schedule. Parallel projects picked up the same model elsewhere. Mongolia's reintroduction efforts, centered on sites including Hustai National Park and areas of the Gobi, followed a similar trajectory starting in the early 1990s, drawing on horses from the same small pool of zoo-bred bloodlines. Kazakhstan later launched its own reintroduction program, moving animals from European breeding centers into protected steppe habitat. Taken together, these programs represent one of the more complete reversals of a species' conservation status in modern history, an animal that was, by the strict definition used by conservationists, extinct in the wild as recently as the late 1960s, now sustaining multiple free-ranging wild populations across 3 countries. None of this erases the genetic reality underlying the whole project. Every Przewalski's horse alive today, wherever it now roams, descends from a founding population small enough that geneticists still track inbreeding risk closely across the entire species. That bottleneck is a permanent feature of the population's biology, not something reintroduction alone can undo, and it's part of why breeding programs continue to carefully manage which bloodlines are paired even decades into the reintroduction effort. The species is a success story with real limits, and the scientists who work on it are generally careful to frame it that way, rather than as a finished, closed case. What the Jungner Basin project does demonstrate, and what has made it a frequent reference point in restoration ecology discussions since, is something narrower but still striking, that a landscape assumed by many experts to be too degraded to recover on any reasonable timescale responded to the return of a grazing species that had shaped it for thousands of years before it was removed. The scientists who were skeptical in 1985 were not wrong to be skeptical. The odds genuinely were poor. The early mortality was real, and there was no guarantee written into the plan that any of it would work. What shifted the outcome was a combination of patient, staged reintroduction, sustained monitoring over a long enough period to let slow ecological processes play out, and, it seems, a set of behaviors buried in the species that resurfaced once the animals were given a landscape that demanded them again. There's a broader lesson conservation biologists have drawn from projects like this one, and it shows up now in reintroduction planning well beyond horses. Ecosystems that have lost a key species don't just lose that species. They often lose a set of physical processes, soil disturbance, seed dispersal, grazing pressure that keeps plant communities dynamic rather than static that were being provided by an animal nobody was thinking of as an ecosystem engineer at the time. Put the animal back, and some of those processes can restart, sometimes faster than anyone modeling the system from the outside expected. It's part of why grazer reintroductions bison in North America, wild horses in Central Asia, and various large herbivore projects in Europe and Africa have become a more prominent tool in restoration ecology over the last few decades, alongside more traditional approaches like tree planting and soil engineering. The Przewalski's horses of the Jungner Basin are not a miracle and not a simple story, but they are a genuine data point in an ongoing argument about how ecosystems recover and about what role, if any, humans should play in that recovery beyond removing the pressures that caused the damage in the first place. In this case, the answer that emerged from more than 2 decades of fieldwork was neither do nothing nor engineer everything. It was closer to identify what's actually missing, put it back carefully, and then get out of the way long enough to see whether the system remembers how to run itself. For a landscape that had been written off by more than one expert in the 1980s, that turned out to be enough.